Hello all, this is S.Vasuki from Computer Science and Engineering Department. So in this video we are going to discuss about neural networks and deep learning concept. So first we have to know about the basics of neural networks. So this already we discussed in the previous video. So first one is a neural network. It is the types of machine learning. So this we quickly recollect the next one is it consisting a number of nodes, so that is called as a neuron. It is used for find out the prediction and finding the patterns. Then next one is a neural network. It is a type of machine learning model which is inspired by the human brain. So obviously it contains the n number of neuron values. Okay, so this is the pictorial representation. First we have consisting of a number of input layer, then hidden layer. So here in this diagram we are consisting two hidden layers and finally it will produce the output value. The next one is a structure of neural network. Here it is consisting of input layer and hidden layer and output layer. In hidden layer it processing the pixel values for an images. In hidden layer it actually computation transforms the input through weights and activation functions. Then third one is the output layer. It produces the final result called the class labels and probability related values. The next one is neurons. So each neuron receives the input and applies a weight and bias and passes the result through activation function. So mathematically it represents as an output which is equal to activation of weight multiplied by input and added with the bias value. So this is the final output. The next one is weight. So what is the weight means? It represents the strength of the connection between the neurons. So what are the values? It may contain the 0.01 onwards. So we can up to processing the positive one value. The next one is the biases. Then it allows the shifting activation function to better fit the entire data. So it is learned during the training period of data. So if you're looking this diagram, the A diagram is called as a biological neuron. Called it contain a deadline and cell body, axon, nucleus. So these kind of data are consisting in biological neuron. Then if you are directly moving on to the B diagram, it represents the neural network diagram. And C represent the deep neural network diagram. So here A is a biological neuron, B is a neural network neuron, C is a deep neural network neuron. How it is actually arranged. Okay. If you are looking at the B diagram, which is neural network diagram, it consisting n number of input. The value starting from x1, x2 up to xn. Then it will be consisting of the respective weights for each and every input data, called as an w1, w2 up to wn. It is called as an weight. So here we have to summation the value. While applying the activation function, we have to apply the summation value. So it consisting of linear operation and also non-linear operation. So if it is a linear operation means we have to sum the value. If it is a non-linear activation means we have to provide the dot operations. The finally it produces the output. If you are looking at this diagram, summation of 1 up to n times, when we have to multiply the input value and bias value. Okay, then we have to finally add the bias value. We have to multiply input and weight and we have to add the bias value. Okay. Then if you are moving on to the C diagram, which is called as a deep neural network. Why it is called deep neural network means it is consisting of n number of hidden layer, which means complex patterns are arranged within that layer. Okay, so that's why it is called as a very deep neural network. Here if you are taking as an x1, x2 up to xn value, it processing n number of hidden layer, transferring the data from one layer to another layer, and finally it produces the output. The next one is the activation function. So add nonlinearity to the model and allowing it complex pattern. The common types of RELU, rectified linear unit, sigmoid function, tau function and softmax function. So it is often in output layer for classification. So this is the activation function. If you are taking as a sigmoid function, tau of x which is equal to, it is the error finding value, which is equal to 1 by 1 plus e power minus x value. If you are taking the diagram, the graph will be represented the before the 0 value. Okay. The next one is a leaky RLU. Here we have to apply the maximum of multiplication 0.1 x comma x. So here the graph will be plotted on the negative value and positive value. Then next tan of x. So here the value will be processed from negative to positive value. It crossed the 0 origin. Then max of, it represents the max of w1 of tx plus bias value, comma w t by 2x plus b2. If you are looking at this RELU, rectified linear unit, means max of 0 comma ix, it falls under only 0th position and positive value only. Here no negative value, false actually. The next ELU. So here we have to apply the x value. If it is a greater than, means it is called considered as an x value. If it is less than 0, means we have to apply the infinite of a power x minus 1. Here the graph values in particular term sustained, then it will be again moving on to the positive value. So these are the various kinds of active functions we are actually used here. The next one is a feed forward propagation. The data falls from input layer and hidden layer to the output, and each layer transforms the data process on it. So this is the simple forward propagation. It consisting a number of hidden input layer and activation function. So this is a deep neural network diagram. Thank you.